Hi, and welcome to Maths Made Easy. Today we're going to learn how to complete the square. Completing the square is something you'll get asked to do all the time in GCSE and high school maths, so it's great to know how to do it really quickly and effectively. So let's get started. Completing the square is something we do on quadratic equations. So we have an equation like this: ax squared plus bx plus c. And completing the square is something we do to this equation, sometimes equal to 0, to write it in a different form that's often useful for certain things like finding the minimum point on the graph. So you know that a function like this will be some kind of curve like this, like a parabola, up this way or maybe up this way, and completing the square can tell us where this minimum point is, which is pretty useful. Okay, so let's see how to actually complete the square. So when you have an equation like x squared plus bx plus c equals 0, the formula for completing the square is this: x plus b over 2 all squared minus b over 2 squared, and we add our c onto the end. So this equation here that I've just written out is just this first equation in a different form, and I'll show you how that makes sense in a little bit, but first let's try an example. So let's imagine we have x squared plus 4x equals 0. So here our b is 4 and our c is 0, and the question says complete the square. So what we do is we just fill out this formula. So we get x plus, and then b over 2, so that's 4 divided by 2 is 2 squared, minus, and then this b over 2 all squared, so that's minus 4 divided by 2, that's 2 squared, and then plus our c, that's plus 0. Okay, so let's simplify that a little bit. So this first bracket we always want to stay the same, and then minus 2 squared is equal to minus, and then the result of doing 2 squared, which is 4, equals 0, and we've completed the square. It's as simple as that. And what you'll notice is if you expand this bracket and simplify it down, so let's just try that. So if you expand this bracket, you'll get x squared plus 4x plus 4 minus this 4 on the end. These cancel out, and we're left with the equation we had in the first place. So it really is just a way of writing our first equation in a different form. Now let's see an example where we have a plus c. So let's suppose we want to complete the square on x squared plus 6x minus 7 equals 0. Actually, let's change it up a bit and make this a negative. Okay, so and remember our formula for completing the square is x plus b over 2 squared minus b over 2 squared plus our c on the end. So let's just have a look here and compare. So our b is minus 6 and our c is minus 7. So you've got to be quite careful with signs when you're doing this. Now let's complete the square. So again, just like before, we fill in our formula. So x and then plus b over 2. Now adding b over 2, so b is minus 6 over 2 is minus 3. So if we add minus 3, we get x minus 3 squared. And now take away minus 3 again squared, and adding our c on the end, that's our minus 7. Now let's simplify this. X minus 3 squared, and then minus 3 squared. Well, minus 3 squared is 9, so we get minus 9 minus 7, so that's minus 16 equals 0. And just like before, if you expanded this bracket, you'd see that you got exactly the same as this original equation, so it is just a different form of writing it. Now, there's one thing that I haven't talked about, and that's what happens if you have something before the x squared. So let's see how that works. Let's suppose we have an equation that's actually in the form ax squared plus bx plus c, because that's our full quadratic equation. When someone writes a general quadratic, it's always in this form because you can have something before the x squared. Now I think what I like to do to complete the square is all we have to do is divide through by the number a. That's one way we can do this. Or another way is we could factor out the a. I think I'm actually going to go with the factoring out the a because it makes the numbers a bit nicer. It's a better way to do it, really. So let's see what happens in an example, because it's best to see from an example. Let's imagine we have 2x squared plus 8x plus c, and our c, let's make that a 4, equals 0. We have to complete the square. Now notice it's not quite the same as before, but it's very close. So what we do is we take out our a. So we do 2, and then we have our x squared plus 4x plus 4 equals 0. So we take out the a from this first bit, we complete the square on this inner bit, and then we combine it all. So it's very simple. It's only one extra step. We have to take out this a, and then we have to put it in at the end. So now we complete the square on this inner bit. So just pretend we're just focusing on this middle bit now. So we'll apply our same completing the square. So we get x plus b over 2, so that's 4 divided by 2, squared, minus b over 2 squared, so that's minus 2 squared, so that's 4. So we've completed the square, just focusing on this inner bit. And then we'll stick our 4 in, because that's not changed. Now all we have to do is expand this back. So the 2 comes here. And now we get also 2 lots of minus 4. So 2 lots of minus 4 is minus 8. Then we add another lot of 4, so that just becomes minus 4 equals 0. And we've completed the square. So you see that's how it worked at that time. We took out the a, we completed the square in the middle, and then we put it back in again. And if we went with the other method I talked about, where you divide everything by the a, we'd get the same equation here, but if we divided by 2, so then we'd end up with x plus 2 squared minus 2 equals 0. They're the same equation, just one is divided by 2. Okay, and that is how to complete the square. Thank you.